So, today we will talk about a topic you probably have used a lot already, CI/CD pipelines. Who has never done in this bachelor degree CI/CD pipeline? Okay, one guy, one funny guy. Now, you have used CI/CD probably a lot, especially if you would do your midterm project or your bachelor thesis, right? And if you have software engineering, you definitely also have learned about CI/CD pipelines. So today we will, in these 45 minutes, talk about CI/CD pipelines and also focusing what does it mean for us when we're talking about network automation, because we have CI/CD pipelines for software engineering project, and we normally do some kind of programming in network automation, but of course we also have other aspects, other information we store in Git, so would be good to have also this in mind. And the next lab I already published will be the task to finish up a CI/CD pipeline, so you have nice merge requests and you can approve them and then merge it. So when we talk about software engineering, this is what came into my mind, where we want to have automation, where we want to have CI/CD pipelines, right? So depending what kind of language we are using, when we want to run our program, we need to compile it, we need to have unit tests, we need to package it, we have to make an artifact. When we are talking about CI/CD pipelines, we have to make integration tests to see if it works together with our other stuff we have. And then of course we need a release process and we need a way to deploy, right? So that's kind of the challenges we have. And if we do network automation, we have the same challenges. Most likely, if we use Ansible or let's say Python, we will not need to compile it, but maybe we have to build a package, maybe we have to push this package to an artifact repository where we can install it afterwards. We most likely have some security checks we have to go through. We have DevSecOps to have some keywords here where we have to comply with the regulations. So this part for a normal software engineering project is also totally valid for our network automation projects, right? So what the solution is, and what you have already used a lot, is CI/CD, continuous integration, continuous delivery, continuous deployment, right? So this is kind of the lecture now, so we're finished. If you understand everything of this, it's totally fine. If you were talking about software engineering, probably this one guy you have heard a lot when it's about agile and all the stuff. So you all know this Martin Fowler, right? He's still active. He still has some articles. He's updating them sometimes. So if you are interested in this, oh, I have some typos, sorry. You can make a pull request, thanks. If you have interest, he has some nice blog posts. He's still updating his old articles. He's contributing in books. And I choose here this one article about continuous integration, and I just took some of his chapters out with typos. So yeah, if you want to deliver something, if you want to build something, you want to most likely automate it, because nowadays we want to have a feedback loop as short as possible. If we do something, we want to have feedback as fast as possible. If it's from the pipeline itself, if the build fails, we want to fix it as fast as possible, right? Because in software engineering or in any project, as if we detect an error or a bug later, it is much more expensive than if we detect it in the beginning. That's also especially for network automation. if we, to say it in the words from Ivan, fuck up at scale, we would really prefer to detect this in the beginning and to have testing. Many times testing in network engineering is not so simple because we still have the hardware, right? If we have a simple software engineering project, we can test, or can have a test coverage to almost 100%. In network automation, if we have a test coverage of, let's say, 95%, we are more than happy because we still have some stuff. We have the hardware. We can run virtual labs, of course, but it's still, in the end, we need also to test on the hardware. So I have seen many projects where everything worked perfectly well. Then we went to the hardware, and the hardware just crashed. Yeah, if you don't test it at scale, you will not detect this until it's too late. And if you run your script against the production, and because of size of the configuration change, the whole router crashes, that's definitely not something that makes you happy. So yeah, we want to have the pipeline also as fast as possible. So if we run the pipeline several times a day, depending how much we commit, how much we make pushes to our branches, we want to have it as efficient as possible, right? In the old programming decades, there could be that a build takes hours. And the goal here would be to have smaller pieces and to be able to test them, to build them. And yeah, in the end, we also want to test it to something that is as close as possible to the production environment. And one big advantage also is the transparency. If we have pipelines and we all the time see how it works, how it is built, how it is tested, for a new engineer, for example, it's much easier to understand what is going on. And I cannot say it enough, testing is extremely important to also be able to maintain some code we are writing, even if it's only Ansible. Not sure if I should say we writing code and Ansible in the same sentence, but if we craft something with Ansible, we need to test it, because there could be an Ansible update, or I have to extend it 2 years later, and if I have no tests, it's a nightmare to know if my change is okay or not. So many projects I have to reactivate after years was only possible because there was a test coverage of, let's say, over 90%. Because otherwise I could not say I'm comfortable that what I updated, what I changed, really can work. So make your life easier, write tests. If you write them before or after, I don't really care. Of course, there is this test-driven development. Who does test-driven development? Okay, that was as expected. I know some people, they really do test-driven development. Yeah, I think it's a nice approach. But in the end, what really matters is that you have the code who does what you need, and you have the test coverage. If you first write a test, or if you write a test afterwards, for me, it's not so important. So just please also try to see how much test coverage you have. All the tools we have out nowadays, they can give you test coverage. You can even visualize it. You have tools where you can see this line is not tested, and you can think, how can I test this line? So for example, GitLab, if you have a coverage report, it will it's not really visible, but in the beginning you have colors, and you pull request, and you can see which lines are tested and which ones are not tested. It's easy to get a test coverage of, let's say, 95% with useless tests. So also please don't just create useless tests to have a high test coverage. Test smart, and always think that you have to maybe maintain this in a year, in 2 years. What if you have to update the library because there's a security issue? So yeah, testing is important for software engineering. But when we're talking about network automation projects, we also need to have other stuff in our Git repositories, right? What kind of Git repositories would you think will we have in a DevOps or in a network automation environment? We have software code, let's call them code repositories. What else could we have? Deployment repositories, yes. So where we describe how we want to have the deployment, configuration, state, anything else we could have. Documentation could be that we have the documentation in a separate Git repository. If it's documentation about the network, that's totally a nice approach to generate the state-of-the-art, up-to-date documentation and push it somewhere so we have versioning. If it's about documentation of the code, I highly recommend to have it in the same repository to always have the same tags and the same version. But documentation of the state of the network, why not? We definitely can have this. Anything else? So, yes? Development repository like for code. Yeah, I would call this code repository. Exactly, for new features and all the stuff, we would have one repository. Of course, we could also have the discussion here between monorepo and multiple repos. Both are totally valid approaches. It really depends how you work, how your team works. So if you have one huge repository with all the stuff there, then the pipeline most likely gets more difficult, but all the stuff is versioned together. So the documentation and the front end and the back end and the templates are all together versioning, but the project gets bigger. On the other side, if you have multiple repositories for templates, for backend, for front end, you have to tag them and you have to have a strategy to see which version of which package is compatible with the other versions. So yeah, that's all the stuff about the code. So if we have, for example, configuration, we most likely have also a lot of YAML files, right? Or configuration files, YAML, TOML, JSON. Yeah. So normally, if we are talking about CI/CD pipelines, it would be really nice to have validation, right? If one of the big things and benefits is transparency, of course, but one other thing is to have this 4i principle that I can create a pull request or merge request depending which tool we're using, different namings, and then we can say someone else has to review my code or my configuration or my template change. And verifying this without tests, without validation of the data is hard, especially if you then have, for example, pull requests with sizes of 10,000 of lines of changes. This is not something you just verify, review between two meetings and a coffee break. So this also needs time, and you have to think into it. You have to think about what could this change have for side effects. As more as you have tests and validate, the easier will be this process as well. So the goal today, of course, is to understand the difference between the terms for CI/CD. Why do we have this? Also, that we think about how could we use this for other projects than just pure code repositories and deployment. Git flow is kind of a basic construct we need to understand to be able to really use the advantage of CI/CD. Who has never heard about Git flow? Okay, most likely you already do kind of all this Git flow stuff. You just did not know that it's named Git flow. There are also different views about Git flow. Important is if we are working on a main branch, we normally also want to have a developer branch, right? The main branch should always be stable, should always be the version who can be installed somewhere. The developer branch also should be more or less stable. The pipeline in the developer should always be green, because from the developer we make a branch for new features, feature branches or release branches, and in this branch we work. So if I have my software or my deployment or my configuration or my template, if I'm talking about Git flow, it means that if I want to make a change, I go to the developer branch, I make a new branch, let's call it feature/Happy Easter, and then I can put my Easter egg in the code. I work on this, I can make multiple commits, I can even make new branches and pull it back. I can work together with someone, and then if I think this is ready, this feature is finished, I then will make a merge request, pull request back to the developer. And as soon as it's merged, reviewed in the developer, then I have it in the developer, and the next time someone makes a feature, it will be in the code base. And if I have a couple of features together, I decide to make a release branch from the developer. I prepare the release, and this will be then merged into the main and to the developer. And in the main I will tag it to have there the release tag. And hotfix, of course, there is always a possibility that we have fixes we have to make immediately, so they have to come from the master. Yeah, this is one of the blog posts or one of the tutorials who can explain all this in graphics if you are not sure. In the end, you have to see what is the best for your project. So if you're working more or less alone on one repository, maybe there is no need for the developer branch. Maybe you work with the main branch and you make branches from there. If it's, how can I say? If you have a huge project and you have different environments or releases, you have maybe multiple developer branches. And yeah, so in the end you have to see what is the best way to go for you, for your team, how you work together. Of course, if you work alone, it's much easier, but for the exercise, for example, we need to have pull requests, and we cannot make pull requests if we only work in the main branch. One other thing highly recommended is protect your main and most likely also the developer branch, that you not push by accident into these branches, right? So you should, in your tool you're using, GitLab, GitHub, Git anything, you should protect the branch, that you cannot make a commit locally on the branch in the main, for example, and push it by accident, because could happen that then the pipeline runs and without any review process your change will be applied to the production. This, yeah, can get ugly. Of course you can revert your git commit, but most likely depending how you have done your CI/CD pipeline. Maybe the change is already applied. Maybe your network is already offline. So then, even if you can make a git reset, head, one back, yeah, the pipeline anyway executed your change. And normally we would say we have everything idempotent, we can just run it again. But if we are offline, there is no way to run it again. So definitely recommend to protect your main branch and work as much as possible in feature branches. Right. And always test. So if you can push into the main and it gets executed to the production and it fails in the production, there are multiple steps that have failed. You did not testing correct, you did not protect your branch correct, and yeah, you pushed an error. So the multiple things had to fail. So normally we want to have some security, some stability. Does not mean that nothing can go wrong, right? There are stuff we cannot test. Like I said, if a device crashes, we have kind of be aware that when we do network automation or infrastructure automation, something can go wrong. And if something can go wrong, at some point it will. So could be that in the middle of our update, a device reboots because of power outage. Shouldn't happen, because we have redundancy and all the stuff. We still need to be aware this could be that this device just reboots. Yes? If we have multiple feature branches, if they have to talk with each other to avoid bugs. Yes. Yeah. Okay, the question is, if we are working on multiple features at the same time, how can we make sure that the end product will not have bugs or collapse or have different issues because of different code bases coming together, right? So in the develop, of course, we need to test everything again. So if we have multiple features working on it and we merge them in the develop, like here, I think, yeah, here all the tests need to be running. And for each feature we are adding, we will also add tests. Because if I write the feature, I want that this is tested, and someone who changes in 2 years some code should not break my feature. Because I was thinking about something, why I did it this way, there's most likely a reason. Or I did not have enough coffee, but I want to be sure that this feature stays there. So I also add tests. And the other feature here also adds tests. And if this feature here will be merged, it will be merged with all the changes we had in the develop and the new changes. There is a high possibility, if we're working on the same files, for example, that there will be a merge conflict. So we have to go there and fix this merge conflict. What the recommended way, in my opinion, is before I merge, I make a rebase. Git rebase would mean that all my changes here are not attached at this point, but they will be attached at this point. So I have to fix all the, for my feature, if I wanted to merge it, I have to fix all the conflicts, and I have to make sure that all the tests are running, and then I can merge my pull request. And another thing is, we should try to not have features so big that we are developing for weeks. So we should have features as small as possible, that we can make the feature and merge it back as soon as possible. Of course, sometimes we have features who need other features, and then we have some more complex stuff, but we should really try to have it as small as possible and always having a running version in the develop. Okay, the question is in a network automation or infrastructure context, how would I do the testing? That's an excellent question. That's actually why we have this lecture here. Digital twin, you mentioned. Digital twin is becoming the same way a term like cloud infrastructure can be everything, depending what you think is digital twin. There are different ways to test. We'll have own module, own lecture about testing itself. So what I see is we need multiple things. We need to be sure that our implementation works perfectly. So we need unit tests for our code, for our interaction with devices. But we also need integration tests, and if possible, we spin up virtual environments and test against these virtual environments our configuration, that we can see that the device accepts our configuration, that the device still talks BGP, for example, that the communication between two clients still is possible. There is multiple issues we have with virtual testing. One is if we have a huge service provider, we cannot spin up 50,000 devices just to test something small, right? So we would need to find out which kind of configuration we need to start up and how can we test it. Could be that we have a really simple or simplified topology, but with all the same features, and then we can test the features there. But then it is not a one-to-one digital twin test, then it's more like a conceptual test if our change would work, right? The other thing is virtual devices are still not the same like physical devices. Depending on the vendor, they are almost the same, but on one side we still have the ASIC, the other side we do everything in CPU. If you have other vendors who are not so extremely nice, you have completely different interface names for easy challenges. But then you also have, for example, other, let's see, BFD. I'm not sure who knows BFD as a protocol. Immediately detecting failures in routing, yes. So what BFD is bidirectional forwarding detection. So it's actually a really simple protocol where someone screams every couple milliseconds, I'm here. And if the other side does not hear that the other person is here, I detect that there is a forwarding issue. And for example, in BGP, I would take the BGP neighborship completely down as soon as possible, because then I can make the rerouting. If I still have to wait that the timer went out for OSPF 40 seconds, depending what kind of timers I have, it takes way too long. So BFD is just screaming all the time. If we do this in hardware, we can scream much faster intervals. If we want to apply the same configuration for virtual devices, because this has to be in CPU, there are some vendors, they have limitation and say, I cannot have a smaller interval than 750 milliseconds. So in your code, you already need to have some distinction between on which platform I run this code. So now I have to make a compromise between how much more logic do I want to have in my automation to handle all these differences versus testing it against hardware. Because yeah, this stuff in the end is also possibility to have new bugs, because I need new features to have availability to test virtual physical. So it's a trade-off. I recommend to test online with virtual devices. There are also some tools who, like Badfish, who can analyze configurations and say, on this device you would configure BGP neighborship, on this device you forgot this one, so there is an inconsistency. There are some tools they also can do this kind of checks. But yeah, in the end, to come to a conclusion, it's kind of a lot of different solutions we have to combine. Does this answer more or less the question? Okay. So yeah, testing is important in our way, and also validation. So if we then add something like a configuration YAML file, we need to be sure that this YAML file is valid. So we need to have steps to validate a YAML file. What is maybe not extremely important but also highly recommended is code formatting, so that it looks nice. If a Python script looks nice or not, it does not have an impact on our code itself. But if we, for example, Python would say we use black as a formatter and we check it in the pipeline, we can make sure that all the code is more or less looking the same. It makes our life much easier if we see new code from another engineer and it looks the same. Right. Also for YAML, there are some linting that we can just be sure that everything has the same quality. So quality of the code is also important for our workflows. I guess everyone has done commits, pull requests, merge requests. So this is in the end something we want. Pull request itself, in my opinion, it is important that we can find something to make it as easy as possible for the reviewer. So talking about network automation, what I, for example, would like is that in a pull request who changes my deployment, I see the change. And if I change in a YAML file something, I would like to know what will be the effect of this change. What is the new artifact I generate? Is the configuration completely different? Is there, if I rename a VRF, for example, on one device, this can have a huge impact on the whole configuration. So the ideal world would be that I can really see the change on the box, what this YAML file does. So that also implies that, for example, when we are doing, let's say, non-neo or Ansible, I have a feature like dry run. I can run it in the pipeline and I can say I would have done this change. This really allows me as an engineer, when I review it, to say that's expected or this is not expected. So that's something we don't really have in normal classical software projects. But when we are talking about infrastructure automation, we really want to know what is the effect it will have on the configuration, on the box. So there we need to have something like a dry run, like a diff mode, depending which tool we're using. If we would use Terraform, would be the plan action. We want to know what would be executed, right? And in the best case, we see it nicely in the Git pull request. Otherwise, I have to go to the pipeline and to the logs and see the diff there. So try to make the life easier for someone who reviews your changes. That also implies we should not make too huge changes. It's not always possible. Sometimes there is a good chance that it makes sense to make a code freeze between Christmas and New Year, for example, and then refactor some stuff, because then you're the only one working on it. This pull request then most likely gets huge. So sometimes you have bigger pull requests, but try to make it as easy as possible for someone for reviewing it. Yeah, pipeline itself normally are triggered by commits, and when we, not directly by commits, but when we push commits, so every time we update the repository on the server, a pipeline can be run. Merge request, for example, also when we push, for example, new tags, we can run pipelines, but we also can, of course, schedule it. If we want to have a really simple backup solution, we can make a script who gets all the configuration and pushes somewhere or upload it somewhere, and we can run it every night. But important is the CI/CD solutions like GitLab, Jenkins, GitHub Actions. There are many more. They are not designed as a workflow engine. So if we want to have a workflow engine, then most likely the scheduler is not the right option for us. But if we just need something and we are too lazy to make a cron job on a server, we could also make a schedule in the pipeline, for example, depending on the complexity. And of course, we can also trigger the pipeline by the UI, run pipeline, or over the API. So that's also something we can definitely do. Most of the solutions, also GitLab, they allow us to import other pipelines or trigger other pipelines. So we can say, if I run this pipeline, I want to execute in this project the pipeline, and I need the artifact from this pipeline, and then I can continue. So we can also make some more complex stuff, but everything always had in mind the classical software engineering approach, right? So this is, just to be clear, no workflow engine. We should not try to bring some business logic or stuff into these pipelines. Only because we can, does not mean we should. So, in the lab you will work with GitLab. So important is that we have the GitLab CI YAML, who is the entry point for our pipeline. One thing you have to be aware is that the ending needs to be the short version and not the 4-letter version. Otherwise it will not detect the file. It is YAML, and it is kind of own language again. So if we look at the reference, it has a lot of features. Will not go to all the details, but it has a lot of features. It's, yeah, you have to look at examples. You can use all the YAML features, of course. So for example, you could use anchors and references in the YAML file, but GitLab itself also has a feature for reference, so you can use special GitLab tags to go to a job and reference to, for example, the before script, and use this again. You can also use the default keyword, especially in the lab. We will need to have the ENS Kubernetes tag that is running on the correct runner, otherwise we will not have access to the hardware. So this could be done in the default, that all the jobs we defined are running with this tag, and therefore selecting the right runner in the background. Yeah, so we'll not go to the deep. We can have includes, we can have a lot of stuff. We can input from the same directory from other projects with references, with SHA hashes. Yeah, so in the end you have to use it. You have to Google some stuff, definitely, because you would all fall asleep if I go through all the features. And if you use another project, another CI/CD solution, it would be slightly different, but the concepts are more or less always the same. So this is a really simple default project for a Python project. Here the tag, for example, as I mentioned, this is an older example at the moment. I think the new infrastructure of the institute has Kubernetes here, so ENS minus Kubernetes. as a tag. The image is a Docker image in GitLab. So we say we have the Docker image with the Python version 3.9, for example, but could be also something else. And in the before script, we normally do something to install. In this case, the project uses Poetry, so we install Poetry here, and we also set caching. There are different strategies for the caching. For example, here we have just a project and then the job name. So for each job name, this will be unique. So each job name will have their own cache. There is also possibility to run this for different versions. I highly recommend to include here the Python version or the dependency versions you have, because sometimes I have seen that after updating, for example, I want to now update to Python 3.12. If I do it in the same job, I will use the old cache, and this can then definitely fail. So I have to log in to the GitLab, I have to clear the cache, and then it will run smoothly. So maybe it's easier to just here add hard-coded the Python version, for example. And I have also seen that if you have a dependency file, that we can make a hash over the dependency file, and if the dependency file and the Python version does not change, then we can use the cache. We don't have to install this. This is the same for GitLab, GitHub, Jenkins, all these tools. Yeah. We have definitely some reasons or some ways to have workflows, because some tasks I want to run on the main, some tasks I want to run on the main and on the developer, some stuff I want to run on all branches, some stuff I only want to run on pushers who push the tag for releasing. So there is a way to have a general workflow rule set in the beginning, but also then for each stage or task we can then say I want to run this or not. There are conditions. Yeah, you have to also find the way. So here in this project we would have inspect, test, validate, diff, dry run and deploy stages. So that's all the stages the pipeline goes through. The deploy definitely only should run on the main. That would look like this, for example. We check formatting. For example, Python would be black. We go here and we say PyTest. We want to ensure that all the unit tests are running. We have JSON schema validation. If we have configuration as YAML or in JSON, there should be some validation there as well. The easiest way, in my opinion, would be JSON schema, where we can define how the YAML file needs to look, which one has to be an integer, which one has to be a string. With JSON schema and Pydantic, we can also then automatically generate Pydantic classes to work with this. And yeah, then we have a diff stage here. So only if the inventory we defined, for example, has a difference, change all the templates, then we will have a difference in the configuration, right? So we can here also see if the configuration will change or not. Diff post. So the idea here on this is to generate the diff we have and then post it as a comment in the pull request as a bot, so we directly see the diff. We don't have to open the log files to see it or the artifact. And then the dry run, who will look if it can run non-near, in our case here, to the device. If the communication works, what would be exactly the change? Yeah. One other small thing would be tests. So if we have PyTest, we can generate artifacts also as a report. Normally artifacts are just files we can upload, we can use. If we define this as a JUnit report, GitLab automatically can visualize them here. So then you can see how long did which test take. You can go to the details, see this. So this also depends on which version you have on GitLab. In the community edition, I think the most used report is JUnit. This is for free, but if you would have the enterprise version, you could have more more insights. But I wanted to show you this just also as a way to make it easier for someone to review your whole pull request. It's two lines of code. If you don't know it, everyone has to go to the log files, so you have it in the UI. You can go wild if you want. This is not active anymore, but this was a pipeline on GitHub who one project triggers a lot of other projects and release branches, all the stuff. So you can automate everything, but you also have to operate and maintain it in the end. So also here it's a trade-off between how complex do I want to have it, how well can I still maintain it. Any questions? Was there something new? So you have used all the stuff, and yeah, if you have any questions in the lab, don't hesitate to ask me. But the lab should be quite simple, and the lab is with the hardware we have. Okay, thank you.